This lesson is the second in a series of 3 videos that discusses how to find area. So this time we are going to be looking at area of a parallelogram and a triangle. And the focus of this lesson is for grade 6s. Before we begin, let's review the big idea for area, which we discussed in the last video. The area of an object is a two-dimensional attribute. So it's a way to describe or to measure an object that has 2 dimensions. And those 2 dimensions are the length and width. You can also combine many shapes together so that it creates a 3D shape, and then you would be measuring surface area. In the previous lesson, we looked at the area of rectangles and squares. So if we look at the rectangle first, we know that it has a length of 12 and a width of 9. The formula for area of a rectangle or square is area equals length times width. We could put the length of 12 and multiply it by the width of 9, and we get 108 centimeters square. Now let's look at the parallelogram. The parallelogram and the rectangle have a lot in common. This parallelogram has a height of 12 centimeters and the base is 9 centimeters. To find the area of the parallelogram, we actually perform the same function. And the reason is that I can take part of this triangle and form the exact same square that's on this side of the screen. So here we go. There we go. So I can take this triangle and I can move it here. And just like that, I ended up with the rectangle that's on this side of the screen. So the difference is that when we're looking at parallelograms, so I'm going to put this triangle back. I'm going to try to put this triangle back. There we go. Whoops, and I took something with it. Okay, so when I put this back into a parallelogram, we know that it has a height of 12. It does not have a length of 12. It has a base of 9. But the formula is the same function. So to find area of a parallelogram, we do area equals base times height. Okay, and again, it's the same function, only for a parallelogram, we use base and height. We don't use length and width. And again, I multiply the base is 9, the height is 12, and we end up with the same mathematical sentence for both shapes. So the area is still 108 centimeters square. So if you have a parallelogram that has the same base and height as a rectangle has length and width, you're going to end up with the same area. Let's look at some quick examples. So look at the green parallelogram. In the book, they're going to try to trick you. They're going to give you this measure, and you have to be careful. That's not the height. This is the measure of the slanted side, and you can see that it's 8 decimeters. But the area for a parallelogram is actually the base, which in this case is 12 decimeters, multiplied by 9 decimeters. And it's the height, and that's why the arrow is pointed to the dotted line. So area equals base times height. Okay. So I have 12 times 9, same numbers as last time, and it's still 108 decimeter square. Let's look at the yellow parallelogram. So this parallelogram has a base of 6.5 meters and a height of 11 meters. And again, I can put my formula in that area equals base times height. Notice that I always write my formula. The base is 6.5 and the height is 11. Now, I can estimate, I know that 6 times 11 is 66, so the answer has to be around 66. And if I put it into the calculator, I know that it's 71.5, which was close to my estimate. So this parallelogram has an area of 71.5 meters square. We answered a question similar to this in the previous video. A pool has the shape of a parallelogram. Its area is 12 meters square. What are the possible bases and heights? So basically it's asking you what numbers multiply together to equal 12. So we know that the area is always going to be 12 meters square because that's given to you in the question. Okay, so always 12 meters square. Now, I could say that, the base could be 1 and the height could be 12. Right? And then that would give you 12 meters square. Now, the base can also be 12 and then the height can be 1 as well. So in this case, it could flip because unlike the previous question, the base is not necessarily the longest side. I know that 12 is an even number, so I know that the base can also be 2 and the height can be 6. And once again, because the base is not necessarily the longer side, the pool could have a base of 6 and a height of 2. And then finally, I know that the base could be 3 and the height can be 4, or again, 4 and 3. So there are 3 possible bases and heights for a pool that has an area of 12 meters square. Let's carry on and discuss the area of a triangle. Now to do that, let's go back and actually discuss parallelograms. So here's the orange parallelogram, and this parallelogram has a base of 8 and a height of 6. To find the area of the parallelogram, we already know that I would do area equals the base times the height. So I would take 8 times 6 and come up with my area. Now, I put this line in the middle of this shape to show you that I could cut the parallelogram in half and I end up with 1 triangle and 2 triangles. So to find area of a triangle, what you're basically doing is you're cutting a parallelogram in half. And that's why the formula changes. So the area of a parallelogram is base times height, but because a triangle is half a parallelogram, the area of a triangle is area equals base times height divided by 2. Let's carry on by actually finding the area of one of the triangles. So I can say that the base is still 8, and it's going to be multiplied by 6, and it's going to be divided by 2. Now I know that 8 times 6 is 48, and it's still divided by 2. Now that tells us that actually that the parallelogram has an area of 48. So the orange parallelogram has an area of 48. Those 2 triangles, which divides the parallelogram in 2 by this line, means that the 2 triangles that are created have an area of 24 meters square. So this triangle here has an area of 24 meters square, and this triangle here also has an area of 24 meters square. The blue triangle and this orange triangle actually have the same dimensions. They're congruent. So if we find the area of one, we'll end up finding the area of both. So let's carry on, and I can say that 7 times 3.5, and we can divide it by 2. Now I know that 7 times 3 is 21, so 21 would be a very good estimate, and but if I put it in my calculator, I know that 7 times 3.5 is 24.5, and then we're going to divide by 2. So if this was one parallelogram put together, the area would be 24.5. Now if I divide that by 2, I should get something like 12, and the answer is 12.25 decimeter square. We could still answer a question that gives you the area, and you have to find the base and the height, but you have to remember that the formula for a triangle divides the base and height by 2. So to go backwards and find the base and height, we have to multiply the number that's given by 2. Okay? So the area of the triangular sail will still be 10 meters square. Okay? However, we have to think that we're actually finding numbers that multiply together to equal 20 and not 10. So the base of the sail could be 1 meter and the height could be 20. Or again, vice versa. It could be 20 and 1. It can also be 2 and 10. It can be 4 and 5, or 5 and 4, and the area would still be 10 meters square. So let's quickly review what we learned in this lesson. First, we reviewed that the area of an object is a two-dimensional measure, and the two dimensions are length and width, and in this video we can include those two dimensions as being base and height. The area of a parallelogram follows the same function as the area of a square because any parallelogram can be cut to become a square. And then we learned that to find the area of a triangle, we have to remember that two triangles together form a parallelogram. So the formula for area of a triangle is half the area of a parallelogram. Can you find the area of these shapes?